Hello Year 6, I'm Miss Tillett and I'm a science teacher here at Kelvin. I'm going to go through with you a lesson today on acids and alkalis. So I need you to make sure that you have your booklet ready with your lined paper, and I'm going to ask you to go through some tasks, okay, together. So the first thing I'd like you to do, can you make sure you've got the date and title, please, written down on the lined paper? And on my slides, you'll see that I've got some starter questions for you. So 3 questions. Start yourself on beginner, okay, and work your way up to challenge and expert. The first question, the beginner question, is asking you to look at those symbols you can see, labelled 1, 2, and 3, and work out which symbol you think would mean the most harmful and which symbol you think would be next harmful, and then the third most harmful, okay? So put them in order from harmful to least harmful. And then the challenge and expert questions you can read for yourself. So I'm going to give you 3 minutes, okay? 3 minutes to have a go at those. Write your answers down. Your teacher can pause me now, and I'll come back to you in 3 minutes' time. Okay, hopefully you've had a go at those and you've written down some answers. So let's self-assess. Now, what I'd like you to do when we are self-assessing, I need you to use a different coloured pen. At Kelvin, we use red pen, but if you are used to using a different colour, say purple or green for self-assessment at primary, use whatever colour you have. So how did you get on? My answers are going to come up now. So the first symbol that you see with the skull and crossbones, okay, that one is the most harmful out of the 3, okay? So this symbol is meaning toxic. Now, why are we looking at these? Because when we use chemicals at Kelvin, our chemicals need to be labelled with these symbols to tell us how dangerous something is, okay? So if something is labelled with that, it means it is toxic, so it could potentially cause death if we use it or if we use it incorrectly. The second most harmful out of those 3 symbols is actually the one that is labelled number 3, okay? So you can see it looks like liquid being poured onto like a bench or some hands. That symbol there means corrosive, okay? So if you didn't get that down, write down that that means corrosive. What that means is if this is on a chemical, it could burn through skin or cause damage to the desk, okay? And then the third one, which is actually picture labeled number 2, where you see an exclamation mark, that symbol means harmful or irritant, okay? So this is the least harmful out of the 3, but it could cause some irritation to our skin, which basically means itchy, all right? So my challenge question asks you, why do we need these hazard symbols? Okay, so we need these hazard symbols to ensure we know the risks, to ensure we know what we are using and how dangerous they are and how to protect ourselves. Okay, so it gives us an indication of how we can make sure we don't get into harm when using chemicals. Now, my expert question asked you, are all acids dangerous? Now, the answer is no. Not sure if you got that. Maybe you put yes. If you put no, well done. Not all acids are dangerous, and that's what we're going to go into in today's lesson about why some acids aren't as harmful as others, okay, and when we might see them in our everyday life. So why are we doing this? When you get to Kelvin in Year 7, one of your first topics is going to be all about acids and alkalis, okay? Now, acids and alkalis are chemicals, and most substances can be described as either an acid or an alkali. Okay, now I've got 2 pictures on the board. I want you to think about which one of those would you describe as more acidic. Okay, now in fact, they both have something in common. They are both acids. Okay, lemons and vinegar both contain acids. Now that taste to us, okay, is often quite sour. Okay, so a sour taste would describe basically an acid. Now, like we said earlier, the acids that we have all around us aren't always going to be harmful. So lemon juice and vinegar we can have in our food and our drink. There's nothing wrong with those acids, okay? Some acids we're going to talk about later are more harmful than these. Now, an alkali is the opposite of an acid, okay? So if acids have a sour taste, alkalis aren't sweet, but alkalis are more soapy. okay? Alkalis can also be called bases. So if you hear me say the word base, or your teacher when you come to year 7 say the word base, it is another word for alkali. So alkalis are also things we might use at home. So I just want you to think, can you think of anything that would be an alkali at home? So here are some examples, okay? On the board are pictures of everyday substances, things you will have seen before, things we can have in our home, in our cupboards at home, okay? And things we can use, all right? Now, some of these are acids, some of them are the opposite, which is an alkali or a base. I want you to quickly talk to the person next to you, okay, for 2 minutes, and decide which ones you think are acids and which ones you think are alkalis. You've got 2 minutes. You can pause the video now, and then I'll come back to you. Okay, hopefully you finished your conversations. I'm going to go through a couple of these, and you can write them down as we go. So, Rennie is a tablet we can take for heartburn, okay? Now, Rennie is an alkali, okay? It helps with indigestion. That's to do with our stomach acid. So our stomach acid is an acid in our stomach which helps us break down food. And Rennies are known as indigestion tablets, so they can help with any pain or heartburn we might have when digesting food, okay? They are an alkali. Vinegar. What did we say earlier vinegar was? So hopefully you got this one. Vinegar is an acid, okay? Apple juice. Now, what did you think? Did you think this was more like Rennie or more like vinegar? Apple juice is also an alkali. Now, you'd be starting to think, well, the difference in the taste between vinegar and apple juice, okay? One is a lot more sour, one is a lot more sweet. So that's starting to help us think about the difference in the strength of these acids. Okay, so bicarbonate of soda. You may have seen this before. If you've done any cooking, any baking, you made cakes, we can use this for that. This is an alkali. Okay, so you can get that down if you haven't already. Bleach. Okay, bleach is another interesting one. Now, I'm going to predict that a lot of you put acid for this one. Okay, if you didn't and you put alkali, well done. Bleach is a very, very strong alkali, and we'll talk about that later on. Coca-Cola or fizzy drinks in general, okay, I'm sure we've all had this before. It is also an acid. Right then, as this has kind of told us, we hear the word acid, we tend to think of danger, okay? But that's not always the case. Some acids and alkalis are safe, and we use them in our everyday life, like it's okay to eat lemon and use soap, okay? But there are some hazards linked to some acids and some alkalis. The word hazard means a danger, okay? So if something is dangerous, like we said in that starter slide, it will have some symbols on the bottle, okay? And that will tell us how dangerous something is. So I've got some examples here. Hydrochloric acid. This is an acid. This is a chemical that you will use a lot when you come to Kelvin. We do a lot of experiments with hydrochloric acid. When we use it, we will see on the bottle it has a symbol. That symbol says corrosive. That's that one I showed you in the starter with the liquid going on the hands and the bench, okay? This means it could burn your skin, all right? So we have to think about what precautions we would take if we are using that acid, how we would basically keep ourselves safe. In comparison to vinegar, okay, vinegar is also an acid. It contains something called ethanoic acid. That's the scientific name for vinegar. So next time you're getting chippy on a Friday, you can try and be really smart and say, oh, I'm going to get some ethanoic acid. That's the scientific name for it. Okay, pure ethanoic acid, if we were using it in science, is very dangerous. But vinegar is less dangerous, okay? In fact, it's not dangerous enough for us to eat it on our food because it is diluted with water. That means the acid is in there, but there is mixture of water in there too, okay? Which makes it not as strong. So vinegar doesn't need a warning symbol on the side. Right, we've got a problem then. Let's say we've got two chemicals that look exactly the same, okay? So you can see in my picture here on the slide that I've got two glass beakers, okay? And inside there are some clear liquids. I've pretty much got exactly the same volume in each one, and also the glass stirrer is just inside, all right? These are both colourless, all right? If I wanted to find out which one was an acid and which one was an alkali, there is something I could do, okay? We use in science something called indicators. So indicators on a car, if anyone uses an indicator or watches someone use an indicator in a car, that's because it's telling the car or the people behind you or the other drivers where you're going. An indicator in science tells us something about a chemical, okay? Not necessarily tells us where we're going, but it tells us some information about it. Indicators contain dyes, okay? And those dyes change colour in acids or alkalis. One of those indicators is a paper. Okay, this paper has a special name. It's called litmus paper. Litmus paper comes in two colours. We can get red litmus paper and blue litmus paper, and they are used for different things. So what I'd like you to write down, okay, on your note page is this information here, these last 2 bullet points on my slide. I want you to make a note that red litmus paper changes blue in alkaline and blue litmus paper changes red in acid. Okay, that's important, and you're going to need that later for my task. So I'll give you 2 minutes now, pause the video, write that down, and then I'll come back to you. Okay, hopefully you've written that down, and I'm going to ask you to use this information now to make a prediction. So, back to our 2 clear liquids. Okay, as a scientist, we want to make a prediction. We want to think about what we might find out, and we're going to use the indicator to work out our answer. Okay, so here's what's happened. In beaker A, okay, the first beaker, the scientist has used blue litmus paper. You can see in the picture, they're holding the paper at the top, and the top is blue. Okay, when it's been dipped into the liquid, it has gone red. So automatically, I hope you're thinking a little bit what this might mean. Beaker B, they've used the red indicator paper, okay? Like you can see again in this picture, it's red near her thumb and it's turned blue. So I want you to work out which beaker is hydrochloric acid and which beaker is sodium hydroxide. Sodium hydroxide is a common alkali that we'd use at Kelvin. Okay, I'll give you 2 minutes to write down on your line paper, A is which substance and B is which substance. Pause the video, off you go. Okay, how did you do? So I want you to self-assess these, look at your answers, give yourself a tick if you got it correct, and if you didn't, write in the correct answer for me. So A is hydrochloric acid. Now, hopefully you worked out because the acid turned red, okay? Well, the acid turned the paper red, in fact. The B beaker was sodium hydroxide, and that's because the red paper turned blue. Okay, now I want you to hold them colours in your mind. Acid red, alkali blue. That's going to be important for our next task. So, back to our idea then. We've got these 2 beakers, and we now know that one is an acid and one is an alkali. But as we mentioned earlier, some acids need a warning symbol on them because they're a lot more harmful. One could be vinegar, because we can get clear vinegar, and one could be hydrochloric acid. How would we know? They would both turn red using the litmus paper. Now, if we want to know then the difference in a strength of an acid, and that will tell us how harmful it is, we can use something else. Okay, our litmus paper would not work for finding out which one is stronger, okay, or which one is more dangerous. Instead, we would use something called universal indicator. Now, universal indicator is amazing because universal indicator can tell us if something is an acid or an alkali and tell us how strong it is, okay? Universal indicator is represented in this picture. I've got a bottle of it here with this, the red lid is a pipette that can squeeze up the liquid so you can drop it on something, okay? Universal indicator is a browny green liquid, okay? And it's made of a mixture of dyes. So it can change colour. It's really amazing. It can change red, orange, yellow, green, dark green, blue, dark blue, and purple. Okay, it can change so many colours. When you get to Kelvin, you'll see this. You'll have a go. Okay, in the first term, when you start in year 7 in September, you'll be using the universal indicator for yourself. Once we've used the universal indicator, we can compare the results, okay? Once we've added it to a substance and it's changed colour, we can compare it to what's called the pH scale. The pH scale tells us how strong an acid is, okay? For example, hydrochloric acid is a lot stronger than vinegar, and I'll show you what that means on the scale. So what I've done here is I've added universal indicator to a number of different liquids in some glass test tubes, okay? What I've then done is put them in order from the pH scale. So pH scale goes from a pinky red colour through to orange, through to yellow, through to green, and then up to purple and dark purple. Okay, already in your head, I want you to think about where the acid is, which ones might be alkali, and why you think that. Okay, if I added universal indicator to lemon juice, it would change red. Okay, so one of these test tubes on the left is lemon juice. If I added it to vinegar, vinegar would change orange. Okay, so it'd be further up the scale, more towards the right. If I put universal indicator in water, it would go green. And if it was bleach, okay, like something you use at home, like Domestos, okay, a cleaning product at home, it would go dark purple. Okay, so already you're thinking, right, yeah, okay, I'm working out because we mentioned earlier, bleach is an alkali, lemon juice is an acid. Okay, so here we go. Here's an example of all different things we might see at home and what colour they would change in universal indicator. Now, if we compared that colour to the scale, we also get what's called a pH number. Okay, so for example, right at the end of the scale, next to the acid, where we see 1, we see gastric acid. Gastric acid is basically the acid we have in our stomach, which helps us break down food. Okay, lemon juice is next to pH 2. pH 2 is slightly weaker than stomach acid, but a lot stronger than something like milk, which has a pH of 6. Okay? Right in the middle of the scale is pH 7. pH 7 means neutral. And you'll notice earlier we said water changed green. That means water isn't acid or alkali. Okay? It's something in the middle. It's neither. As we go up the scale, we get things that are more alkali. Okay? So egg, pH 8 is a weak alkali. Bleach, pH 12, is a stronger alkali. Now, what I want you to do is using this information on the pH scale, using the numbers you can see and the labels you can see with acidic, alkali, and neutral, I want you to answer these 5 questions. Okay, so write down 1 to 5 on your piece of paper. Each of your answers is going to be a number. Okay, next to your number, you need to write pH, little p, capital H. I'll give you 3 minutes to do that. So pause the video now, and then I'll come back to you with the answers. Okay, hopefully you've done that. We're going to go through the answers. So number 1, the pH of the strongest acid is pH 1. Okay. Number 2, the pH of the weakest alkali is pH 8 because that's closest to neutral, okay, on the alkali side. The pH of neutral is 7. The pH stronger than a pH 12 is pH 13 or pH 14. And a pH of an acid weaker than pH 4, okay, is pH 5 or pH 6. So using your different coloured pen, can you check your answers, give yourself a tick if you got that correct, add it in if you made a mistake, okay, change the answer or add in next to it if you made a mistake in your different coloured pen. I'll give you 2 minutes to do that. So pause the video now if you need to, and then we'll move on. All right then, hopefully you've managed to get them answers down, and I'll be interested to see how many 5 out of 5 there were. So well done if you got 5 out of 5. So moving on then. What I'd like you to do now is apply your knowledge to what we've talked about, what we've gone through. So in your booklet, you should have a pH scale worksheet. There are 5 tasks, 5 questions, and I am expecting most of you to be able to get to task 4 minimum. Okay? The first 2 tasks, you need to use the keywords in the box to complete the sentences and the diagram. The next tasks are asking you more to apply your knowledge to different pH or pHs of solutions. Okay? So I'm going to give you 10 minutes now. Pause the video, complete the tasks in your booklet, and then we'll mark them after the 10 minutes is up. Okay, well done for working really, really hard on that. We are going to go through the answers. So again, using your different coloured pen, like I said at Kelvin, we use red. So whenever we're self-assessing, we use red pen. Use your different coloured pen to mark through your answers. So the first question was asking you to fill in the blanks in the sentences. The first word you were missing was red. The second word you were missing was blue. And the third word you were missing was green. So give yourself a tick for each of those keywords and or correct it if you need to. Question 2 then. You had to fill in the keywords onto this picture of the pH scale. So at the top, you should have the words or the letters pH, okay? If anyone can clock my mistake on this slide, bonus points to you. It shouldn't be a capital P, it should be a little p, a capital H, okay? So if you notice that, well done. Next section then. On the left, where it's 1 to 6, should say acid or acidic. In the middle, next to pH 7, should say the word neutral. And from pH 8 to pH 14 should say alkali. Okay, well done if you got that. Question number 3. Our answers are pH 7, pH 14, pH 5, pH 9, and pH 1. Okay, so this was asking you to apply your knowledge of what you know about the scale and how strong or weak an acid or an alkali are to the pH numbers. Okay, so give yourself a tick for each of those and or correct if you need to add in any answers. Okay, question 4. Question 4 was asking you to use that information table. So A is lemon juice or rainwater. B is water or blood. C is washing up liquid, sodium hydroxide or oven cleaner. D, carbonic acid or stomach acid. I'll just leave that on for you. So if you need to pause now to write those down, pause. Okay. And lastly, question 5. How do we protect ourselves if we are using a harmful chemical? So we wear goggles. When you do practical experiments at Kelvin, you will wear goggles, okay? You may potentially wear gloves in some cases. And also be careful to clean up spillages carefully and wash your hands. Now, you might have got lots of different answers for this one. I would recommend that you pause the video now and ask your teacher or ask your peers next to you who you're sat with for their answers, and there'll be lots of different answers for this. So have a go, talk to the person next to you, ask your teacher if there's anything you want to clear up on this one. So I'll just give you 1 minute on that one and then we'll move on. Okay, the last little bit of the lesson then. I'd like you to write these answers again on your line paper. So well done for completing the worksheet. We're going to go back to the line paper. Now, we've had a scenario today. You never guess what. A box of chemicals has been delivered to science today at Kelvin, but all the labels have fallen off in transit. The technicians who are in charge of setting up all our chemicals can't tell which chemical is which. I would like you to help them. Can you help them today? The technicians said when they ordered them, okay, when they ordered these chemicals to be delivered, one they know should be a weak acid, one chemical should be a strong alkali, and one should be a strong acid. And I want you to help them by telling them how they would find out which one was which. So, these are my tasks. The bronze, I would like you to tell me how they would use universal indicator to find out which one was which, and I've got some sentences to help you with that. For the silver question, so working your way up these tasks, I want you to explain why the science technicians should use universal indicator and not litmus paper, what we mentioned earlier. For the gold task, I would like you to explain why it's so important that the scientists can tell the chemicals apart. Okay, you're going to have 5 minutes. Start yourself on bronze. Once you've finished, move yourself up to silver and then have a go at the gold. Okay, 5 minutes now, so pause the video and then we'll come back to the answers. Okay, so hopefully you've had a really good go at those. We're going to go through the answers now together. Again, you need to self-assess, please, in your red pen or your whatever coloured pen you're using and give yourself some marks for this. So our bronze answer then. How should the scientists tell them apart? They should use universal indicator. Those are our first 2 keywords. If it is an acid, it will turn red. And if it is an alkali, it will turn blue. Okay, so they are your other keywords to fill in there. 4 out of 4. Give yourself a mark. The silver then, why aren't we using litmus paper? We aren't using litmus paper because litmus paper will only tell us if the liquid is an acid or an alkali. And we know that one of those was a strong one and one was a weak one. We want to know the difference. So universal indicator will also tell us the pH. Okay, and that will help us understand the hazards, how dangerous those substances are that the technicians are using. The gold task then. Why do we need to know this information? Because strong acids and strong alkalis can be very harmful, okay? Linking back to our starter question, those hazard symbols that we find on the bottles, strong alkalis and strong acids can be corrosive. They can cause damage to the skin. So we would need to use that when working with chemicals. We'd need to know that information. Okay, so look at my answers now. Pause the video for 2 minutes, correct your answers if you need to, and then we'll move on to the last task. Okay, well done year 6 then. This reaches the end of the lesson. What I'd like you to do, just finish off, is write a tweet about what you have learned today. So using 140 characters maximum, that includes spaces, okay, and punctuation. You need to summarize what you've learned today into 140 characters. Okay, once you've done that, I'm sure your teacher won't mind if you want to peer assess them, share them with each other, talk about what you've learned today and share them with your teacher. But well done year 6 and looking forward to meeting some of you in September. Bye.